I'm going to explain what bootc is if you don't know what it is. It's an operating system that you can define and manage the lifecycle through a regular old Linux container image, so a Dockerfile. I've found that defining an operating system with an OpenClaw service all ready to go is pretty cool. So what you get with this is, some people call it an immutable operating system because most of it is read-only. The read-write directories are like Etsy or your home directory, but this offers a very powerful sandbox or a very powerful security feature when you define everything about your operating system at build time, and at runtime you really are limited with what you are allowing to happen. So let's demo how this works with Fedora, bootc, and OpenClaw. So first of all, let me show you the container file or Docker file. It's the base image is Fedora bootc. A bootc image has the Linux kernel included. It's a special container image. You can push and pull and even run as you would any container image, but it has the ability to be transformed into a full disk image like an AMI or a Google Cloud image or QCOW or ISO. So in our container file, we're defining the OpenClaw user, adding some packages, and we are adding the OpenClaw service and another service called the Service Gator, another project in Lobster Trap that's pretty cool. So it's an MCP server that helps to manage your GitHub, GitLab, Jira personal access tokens, along with configuring the scope of those access tokens. And we're just going to run it alongside OpenClaw. So back to TankOS in our container file. There are some cloud in it. You can look upstream at all the documentation for bootc to get more information. But some other things in this that will be baked into this image are some binaries. I've added a wrapper around the OpenClaw CLI since we will be running OpenClaw in a container. This wrapper simply finds the Podman container, and when you run OpenClaw command, it actually goes inside the container, does a Podman exec, and runs OpenClaw that way, and it is unbeknownst to you. It feels like you're just running the OpenClaw command, but it's actually running inside the container. And this is a neat script to take some Podman secrets and sync them within the OpenClaw config. And so once we get our virtual machine up and running, I'm just going to create some Podman secrets from my Anthropic, my Open Router, my OpenAI keys, and then I'm going to run this tank OpenClaw secrets to sync them into the config. What else do we have? So this actually is not built into the current image, but I'm going to use this added binary to show you how to do an update once we're up and running. The systemd services with Podman, we're using Quadlets, which are Quadlets are a Podman specific systemd service, but basically there are two, and they're running the OpenClaw service, which is, and this is running OpenClaw from an image in a container. I haven't pinned to a version because OpenClaw is moving so fast that I want to just keep updating with the latest features. But obviously, this is not a good idea. You should pin it to a version. But for now, our OpenClaw service is running the latest. And the other service is this Gator service that helps to handle those secrets. You can do all of this without Podman Desktop. However, there is a bootc extension within Podman Desktop that makes the two steps to get to your virtual machine very, very easy. And so I'm going to use Podman Desktop, but I'll point out if you don't use Podman Desktop, how you would do it otherwise. So this, if you haven't seen it, it's very similar, I would say, to Docker Desktop. With the exception, there are some extensions. If you go to the catalog and search for bootc, you'll find it. I've already installed it, but if for you, you would have an option to install it all these extensions are themselves container images, so it's kind of cool. But I've already installed it, so now once you have an extension installed, you can access it over here by just clicking on it. Bootable containers. I've already run my podman build command to get my bootc image. It's the tank OS. So what I did is I ran podman build with the path to this Dockerfile container file. And I pushed that to my registry here, and it's living in my Quay registry as the tank OS latest. I pushed a multi-arch image, so if you would like to try this demo out, you can simply pull down this image. It's public. And if you're on a Mac, it will pull down the right one. If you're on Linux, we'll pull down the right one. How do I get a disk image? Because I told you we're going to run a virtual machine. In order to run any kind of machine, you need a disk image. So I'm going to choose my tank OS. Do that again. I'm going to choose the tank OS latest, and this icon here, maybe not intuitive, maybe it is, but you click on it and now I get the build disk image screen. So because I'm on a Mac OS, the QCOW is what will spin up a virtual machine. So I am going to choose QCOW, but you could also choose an AMI or a Google Cloud image or all of these, any of these other ones. So or multiple, apparently. I didn't know that. So I'm just going to build the QCOW. It detects that I'm on my Mac, so it's highlighting the Arch 64 and the XFS. I do not think you can multi-arch build these disk images. So if you wanted a AMD Arch disk image, you need to move to an AMD. Now, what else do I need to provide to get my disk image? In the container file that I showed you, the user's name is OpenClaw, so I want to start always with that user. I'm not giving a password because I don't want to access the virtual machine with a password. I do want to give it just the public SSH key, so I'll grab that here. In order to run bootc upgrade or update my virtual machine, I do need to access elevated privilege. So I am putting my regularly non-root OpenClaw user in the wheel group so that I can gain privilege when I want to. By default, it runs as non-root. I do not need anything else. I just gave it the username and the public SSH key and the group. You can check out these advanced features on your own. And I need to provide a directory. Outtank OS is the output folder. This is where that disk image is going to be built. And we're ready to build. So what is this building? This is building a disk image from a container image. And how does it do that? There is a tool called bootc-image-builder, and it runs from an image. So the entry point of this image here is a binary called bootc-image-builder, and it takes these flags. It needs to know what is the container image that I should start from, where is the output, what type disk image are we running, what's the architecture, and what's the type of root of S. And now the build is happening, and whatever needs to happen to build a disk image is happening. And so again, let me explain what we're doing. We have a container file. We built a container image. We took that container image and now we're building a disk image. It's a special container image with the Linux kernel included. If all goes well, we should be able to spin up a virtual machine on our Macs with that disk image, or in the AWS EC2 instance, or maybe a Google Cloud machine or something else. Okay, we have our disk image. So we went from container image to disk image, and now we're going to create the VM. And you have to give a path to the QCOW. The username and the SSH key. Remember, we pasted the public SSH key, you just give the path to the private one. And it's telling you your virtual machine is ready. Go to Settings, Resources to find your virtual machine. And so it's here. And let's start it. The Settings Resources is where you'll also find your Podman machine that's running all of your other Podman containers. So there's an option to access the terminal here. You can also access it from the boot CVM details. I don't usually access the terminal through this Podman machine, but I'll just show you that it works. OpenClaw is running, great, but I haven't provided my secrets yet. I haven't provided my API keys. So if I try to use OpenClaw right now, it won't work. In the provisioning doc, there's a section for local macOS VM. To access your VM from the terminal, you need to find the port from the GV proxy logs. So I will do that. And it's 58127. I'm going to also need that here. So I'm just going to, and then you should be able to SSH in. And here I am in my OpenClaw Fedora bootc machine. And you can see the gateways up and running. If you look at these logs here. If I try to access it though, I'm not going to get too far because I do not have any model providers secrets configured. I can show you this. So you can see I can access the OpenClaw CLI with our handy CLI wrapper that I showed you earlier. In order to access the UI, you actually have to set up an SSH tunnel, which is why I also exported the port over here. So now that that's running, I can go to my browser. I do need the token. And in order to get the token, this is usually the way to do it. The OpenClaw dashboard, no open. So let's get that info here. And you can see I don't have any model providers configured or API keys. So if I try to talk to my agent, it will fail. So let's fix that. I'm going to set up my secrets. How do I sync these with my OpenClaw? I've created a little bit of a script to do that. By I mean Codex and I. All right, so first I'm going to create Podman secrets. Again, this is in the model provider stock. What am I doing? I am creating Podman secrets that I will then convert to secret refs within OpenClaw. So it wrote the drop-in files for the OpenClaw and the Service Gator systemd service, and it did find my 3 OpenClaw secrets. I don't have any Service Gator secrets yet. So now I just need to restart. And now that we synced the secrets, the OpenClaw service is back up and running, and we should be good to go. Okay, so I had a few problems with my secret sync and the model picker. And so I worked with my AI agent on the side to fix those. So now I do have my agent up and running, and I do have the models that the model choices that I want from the API keys that I gave showing, and everything looks good. I want to make sure that I build a new image with these changes that we fixed, and I'm gonna push that up to the registry, and then I'll just update my entire system, and that'll probably round out this demo. And so, yep, OpenClaw is running. Now that you're up and running in your operating system with OpenClaw service, you can operate as usual with any OpenClaw features, commands, plugins. So yeah, see, you can install plugins, you can do all of that. So now this is what I want to do next. I'm going to exit out of the VM, and I made some changes here to the sync secrets script. So in order for those to go into the default operating system, I patched them in place to show the recording. I probably edited it out, but now we're just going to build a new plain old container image. Once you have that initial disk image and you're installed on a system, you don't need the disk image anymore. Now your updates and your rollbacks and all of that is just managed through plain old container images, which is why bootc is so cool. I'm going to build my new image. Podman Farm Build is a cool way to build multi-arch images. I have an AMD 64 system running alongside my MacBook. It's a Intel NUC, and I use Podman Farm Build to do a remote build, so I don't need to use the emulation. All right, so the new image is pushed to Quay. I'll show you that real quick. And you can see it was just pushed a few seconds ago. So now I'm going to SSH back in. This is why I put the OpenClaw user in the wheel and gave access for elevated privilege, because in order to run a bootc upgrade, you need to be root. So first I'll just do bootc status. So my whole operating system is this digest. I'm going to run a bootc upgrade. And what happens is it goes out to find this tag and compares if it doesn't match this digest, it will pull down the new layers. And so you can see if you have a fleet of these OpenClaw machines and they all, it's time to update, they all just reach out to a container registry and check for a new digest and pull it down and boot into their update, which is what we're going to do right now. And with the latest bootc upgrade, I brought this in that was new in the container image, the OS version. So finally, we went from a container image to a disk image to a virtual machine. And you too can do this if you follow along with this repository to get yourself a bootable Linux appliance running OpenClaw. And once it's up and running, you have full access to the OpenClaw CLI, and you can update and modify anything in your operating system by changing either the container file or the rootfs files and rebuilding the container image, pushing it to the registry, and running a bootc upgrade. I hope you think this is as cool as I do. Maybe you have a lot of machines where everyone gets its own OpenClaw interface. Maybe you want a fully locked down, sandboxed OpenClaw host with mostly read-only image managed operating system. Transactional updates through bootc instead of ad hoc host package changes. So maybe you have a fleet of machines that aren't a hodgepodge of changes. They all are managed through one central container image. Ask your agent for help.